Go through our lesson 21 from Unit 5. So this is our first day on the quadratic formula and the discriminant, okay? All right. So, so far, what we've done is learned how to do solving quadratics by taking the square root and by factoring, okay, which was lesson 19 and 20. And then here, what we're going to do is we're going to do solving quadratic equations using the quadratic formula and the discriminant, okay? And then you should do the graded practice, which is the end of this Desmos activity, okay? So make sure to do the lesson 20 and 21 Desmos practices and then the new quest homework all by Monday at 10. Okay, those will all be quarter 3 grades. And then for this Friday, things that you can work on, the grade recovery for Unit 4, Unit 3, and then again the old quest assignments and the old math quill and the old exit tickets in Canvas from this quarter, okay? Alright, so that being said, let's get rolling, okay? Okay, so here you see we got a little warm-up of what we've learned so far. So remember, one thing we're supposed to do is always write things in standard form, okay? So if we were going to do this here, my first thing is going to be, hey, let's write this in standard form, which means I'm going to subtract 3x from both sides. So I'm going to actually use this down here. I'm going to write my equation, 3x squared, and then I've got minus x plus 1 equals 3x. And then what we're going to do here is we're going to minus the 3x to both sides. So I'm going to minus 3x minus 3x. So that's going to leave me with 3x squared. And then remember, this is like a negative 1. So negative 1x and negative 3x gives me negative 4x. And then I'm going to bring down my plus 1. Okay? Alright, from here, remember the two methods that we've worked on is solving by taking the square root and solving by factoring. We can't solve this with taking the square root because we have a variable term here of x to the first. So we could try and solve by factoring. Remember, when the coefficient is something other than 1, we do this term, the a term, times this term, the c term. So 3 times 1 here is 3. And then I would have to add to this middle term, which is negative 4. So that would give me negative 3 and negative 1. And so now we're going to bring these down. So here we go. We got 3x squared, and then we got negative 3x, and then the negative 1x, and then the plus 1. And then all of that equal to 0. So now I'm going to just factor my GCF out, which would be 3x here, and over here would be negative 1. So that's going to leave me with 3x and then x minus 1. My GCF here of negative 1, when I divide by negative, the signs are going to flip. So I get x minus 1. Again, remember, for factoring, we know we're correct here if the two interior factors match, and they do. They're both x minus 1. So I'm going to write that one time for the x minus 1. And then the two GCFs, the 3x minus 1, would form my other factor. So the 3x minus 1. And now we're going to solve each of these, okay? So I've got this. Remember, I'm going to set it equal to 0. So if I do that, I'd have to add 1 to solve it. So then that would leave me with x equals 1. So that's one of my solutions. And then here I would add 1. And then I would be left with 3x equals 1. And now I'm going to divide by 3. Divide by 3. And that leaves me with my other answer, which is x 1 equals 1 over 3. So these would be my two answers that I would jot down up here. X equals 1/3, and then comma 1. Okay? Now on this side, I'm actually going to solve this by taking the square root because there is no x term. Alright, so let's refresh our memory on what we do with that. So to solve by taking the square root, we're going to actually go ahead and get the x squared part alone. Alright, so in this case, what that means is I'm going to add 20 to both sides. I go plus 20, plus 20, and now that brings this down. 4x squared equals 20. Now I'm going to divide by 4 on both sides. I do that and I get x squared equals 5. Now I'm going to square root on both sides. When I do that, one thing to remember from that first lesson, lesson 19, is we have to put a plus minus to obtain both of our solutions. So then this is what we're going to end up with. X equals plus or minus the square root of 5. Now you can write that a couple ways. You can write that just with, like, here, I'll show it with the math writing. So X equals, okay, and then for my keyboard, I'm going to put in, my plus minus. I could write plus minus like that, which works fine. And then square root of 5, you could do it that way. You could also just write it where you put the positive 5, and now I put the square root of negative 5. If you prefer to write it that way, that's fine too. Okay? Alright, and then here, this is just a review from our previous bit. So I to the 12th, so remember I to the 12th, if we break that up, it's like I to the 4th 3 times. So I to the 4th, I to the 4th, and I to the 4th. Well, we wouldn't have any remainder, because that would be 12. And remember, I to the 4th is just 1. So this is like 1 times 1 times 1, which is 1. Now I need to add that with I to the 21st. So that's like I to the 4th 5 times. So I do I to the 4th 5 times. And then the key that we really want here is what's our remainder. So in this case, I to the 4th 5 times would account for 20, right? 4, 8, 12, 16, 20. So we're left with just I. Remember, all these I to the 4ths are just 1. So this is really like 1 times 1 times 1 times 1 times 1 times I. So it's going to be I. So I'd get this right here, which is in the correct format. So I write 1 plus, plus I. You could write it that way, or if you do the type math to get it that way, then you can also do it in this sense and type the 1 plus I. And that would look slightly different, not much so, but you get 1 plus, and then I. So it'd look like that. Okay? Alright, so we already worked through factoring and taking the square root, which is what I did here on slide 2. So now today we're going to switch to what if that doesn't work? So what if there's a b value, so there's a, a value of b, so there's, 2x, negative 4x, whatever. So you can't do taking the square root. And then when you try to factor, and you're here, for instance, no numbers work. So then what? Well, we still have some methods, and one of those methods is to solve by the quadratic formula. Okay, so you still want to get it in standard form, so ax squared plus bx plus c equals 0, and then you use the quadratic formula. Okay, so let's focus on some things here. What does the plus minus mean? It means that what value we have inside the radical will help us form our two solutions. One as a positive value and the other as a negative value. Okay? So how do we use the plus minus? Well, all we're going to do is basically work our way down the entire problem, and then at the end, we're just going to leave it as the plus minus with what's in the radical. The only time this would be any different for the plus minus is if this radical becomes a perfect square. Okay, and then we look to see if we can simplify. Alright, so let's look at an example. So here we see 2x squared minus 11x minus 21 equals 0. So it's already in standard form. So now we need to label what a, b, and c are. So remember, a is the coefficient in front of x squared, so it would be 2. B is the coefficient in front of x, which would be negative 11. C is just our integer here, which would be negative 21. Now we're going to substitute the values of a, b, and c into the quadratic formula, which again is just this formula right here. And then we're just going to simplify the radical. So like you can type this straight into Desmos calculator. Negative 11 squared minus, negative 4 times 2 times negative 21. It will give you positive 289. Now, in this case, the 289 is a perfect square. The square root of 289 is 11. So now, this is where we're actually going to have to split up to find our two solutions because this was a perfect square. If this isn't a perfect square and it can only simplify, you don't end up having to do step 5, okay? Alright, so now we go 11 plus 17 divided by 4, 11 minus 17 divided by 4, and then those are our two solutions. Okay, so we get 7 and then negative 3 over 2. Alright, so let's show one here. Okay, so here's what we see. Okay, so first thing first, alright, we see this scenario right here. Alright, so I'm going to set this up with quadratic formula. Alright, so I need to write this as negative, and now the b value is negative 3, so I'm going to do negative, negative 3, and then I want to do my plus minus, okay, so I'm just going to write that in now, and now my square root of, and now I'm going to go parentheses, b squared, so b again is negative 3, close parentheses, times, okay, and now for that I'm going to do my value here, times, so 3 times the a, notice here, b squared minus 4 times the a value, which is 2, times the c value, which is negative 5, okay? And now we do all of that, and we're going to divide it by 2a, and the a value is 2. Okay? So that's what all that mess should look like. Okay, so now I want to put this into a calculator to figure out what it's going to be. Okay? Oops, I made a mistake here. I need my squared term on that. So that's a key. Make sure you have that as b squared, so negative 3 squared. Okay, so now that's what I see right now. Now, how am I going to go through and do what I need to do? Alright, so I'm going to open up, and then I'm going to use my calculator here, and I want to figure out what this is going to be. Alright, so when I see the negative 3 squared, right, so let's type just that part in. Okay, now we're going to get our value. So this is what we need to do. So negative 3 squared is 9. So it's 9. And then you do negative 4 times 2 is negative 8. Negative 8 times negative 5 is going to give us a positive 40. So then that is going to add to 49. So what we're really going to get here, remember minus a negative is really like a positive. So you get 3 plus or minus the square root of 49 over, well, 2 times 2 is 4. Well, now we look for this. Oh, the square root of 49, that's 7. So since that's a perfect square, we're going to write 3 plus or minus just the number 7 over 4. And now to get our two solutions, we do one with the positive 7, so 3 plus 7 divided by 4. We do the other one with the minus, 3 minus 7 divided by 4. 3 plus 7 is 10 over 4, which you can change these to a decimal if you prefer. I'm just going to keep it as a fraction, so I divide that again by 2 to get 5 over 2. 3 minus 7 is negative 4 over 4, which would just give us negative 1. So then those are our two solutions. 5 over 2, or obviously 2.5, and negative 1. Okay? So that's how I'd write that. X equals those values. Okay, so just a quick one on something else here that we need to look at. So what is the discriminant and what the heck does it mean? So notice the square root is not part of the discriminant. The discriminant is just the b squared minus 4ac. So it's the part of the quadratic formula that is under the discriminant, as you can see right here. But when you find just the discriminant, it doesn't include the square root itself. So we write the equation in standard form, we identify a, b, and c, and now we're going to substitute it into just this, b squared minus 4ac. Okay, so let's find the discriminant in this scenario. So I see that it's b squared minus 4ac, so this is a negative 4, so I'm going to go in here, and I'm going to go parenthesis, negative 4 squared minus 4 times a, and again a here is 1, times c, which is negative 13. Okay? Alright, so negative 4 squared is 16. So again, what am I going to actually get here? I'm going to get 16. Negative 4 times 1, obviously, is just negative 4. Negative 4 times negative 13. A negative times a negative is a positive. So you're going to write your positive, and then you're going to do, since this is just 4 times 13, so 4 times 13 there is going to give us our 52. And now I'm going to add these together. So 16 and 52 is going to give me 68. So we would just say that the discriminant is 68. Okay? So what the heck does that even mean? Okay? Well, the discriminant is going to tell us what kind of solutions that we are going to get. Okay? So this is a certain type. It's a positive number, and it's not a perfect square. That's going to mean something for us. Okay? So there's a thing that you want to look for when you're doing the discriminant. Okay? You want to find your discriminant and then say what the solutions are. And when you do that with the quadratic formula, then that's going to tell you what kind of solutions you will get. Now, this is only part 1 of our lesson on quadratic formula and discriminant, so we'll get more exact about what it means when you get these different discriminant values. But the main ones you want to look for are when you solve them and what you can get. So you can get 2 non-real roots. What does that mean? That means your answer is going to come with an imaginary number. You get that when the discriminant is negative. So if you have a negative discriminant, your solutions are going to be imaginary, and they're going to be 2 of them. You can get a discriminant where it causes you to get 2 real roots. This is generally our most common one, and that's going to happen anytime the number is positive. So you get 2 real roots like you get here. Or you can get 1 distinct real root. And what that means is basically you do get 2 answers, but you just get the same answer 2 times. That only happens when the discriminant is 0. And that's the only time with the quadratics here where you're just going to write the 1 solution. Okay? So that's what the discriminant looks like. Make sure you work through screen 8, and then you can check your answers here on screen 9. Okay? So just some conclusions about what the discriminant means that we just mentioned. If the value is negative, in other words, if it's less than 0, that means you're going to get 2 non-real roots. If the value is 0, you're going to get 1 real root, which is technically called that repeated root, okay? Meaning that it basically happens 2 times. And if it's positive, if it's greater than 0, you can get 2 real roots, okay? Alright, and then just if the discriminant's a perfect square, that means you can factor it, okay? So on the ones we did before, technically you could have factored them because the radicals simplify just into a perfect square, okay? Alright, so then here you have some to try and check, and I'll just kind of show you what that should look like. So here this asks you to rewrite this in standard form. So remember, what does that mean? We do the ax squared minus bx plus c equals 0. So notice how we rewrote those in standard form. Determining the discriminant is just b squared minus 4ac. Once you know the discriminant, then notice this is a positive number. This is a positive number, so they're going to get 2 real roots. This discriminant was 0, so it's going to give you 1 real root. This discriminant was negative, so you're going to get 2 non-real roots. Okay? Alright, so then in terms of, hey, can this be factored? Like, could you have done this with factoring? Well, it can only be factored if this is a perfect square. Well, technically, right, 0 is, 9 is a perfect square, and obviously negative, you can't factor if it's negative, and 73 is not a perfect square. So you could not factor these bottom 2, but you could factor these top 2. Okay? Alright, and then the practice for the remainder of class is to work on screens here 14, 15, 16, and 17. Find your discriminant, tell us what type of roots they are, say whether you can factor it based on whether it's a perfect square, and then show all your work and pick your solution. I hope this video helps.